Yes.
Oh, okay. Okay, so the first problem I wanted to do from chapter 7 was this example here where it gave us a sine and it told us that it was oscillating with a frequency notated by omega, and it told us that omega is a function of base, height, velocity, density, and this elastic constant k. It told us that the elastic constant k was in terms of force times length, and it wanted us to find a set of pi terms suitable for this problem. So we know that omega is typically in radians per second, which is time to the negative first, so that one has to be our first non-repeating term. We also know, writing out the units for each one of these variables, that there are two with a single unit of length, and so one of them has to be a non-repeating term. So I chose my base to be the non-repeating term. The other one is we need something that has force in it to be one of the non-repeating terms, so that's going to be our k value, which is our elastic constant here. And then the next thing is we also know that you can only have either mass or force. You can't have both of them. So instead of taking our density in terms of mass times length to the -3, which would be kilograms over meters cubed, we need to convert that into something with force, since we need to get rid of our mass term here. So we know that our force is typically in units of newtons, which is a kilogram meter per second squared. So that gives you mass times length over time squared is equal to our force units. And when you solve for that, then you end up with your mass is also equal to your force time squared over length here. And so we can plug that in to our mass length cubed, and that ends up with force length to the -4 times time squared. So from here, we want to set up our first pi term, and so we know that in this equation we have 6 variables in 3 different dimensions, so we're going to have 3 total pi terms. So for the first term, we're going to choose our first non-repeating term, which is our omega, and that's going to have to be in a function of all of our other repeating terms, so height, velocity, and density. So you want to set that up and do your omega times your next one, which is your height, length. You're going to set variables for each one of these, and they need to be equal to 0 because we know our pi terms are dimensionless. So when you go ahead and set up these variables and solve it out, we end up with a equal to 1, b is -1, and c is 0. So we know our first pi term is going to be omega height over velocity. And then so now we need to go to our second pi term, which we can see our next non-repeating term is our base unit. So that is in terms of length. And so this one you can set these up, but it's pretty obvious that for length you're just going to have to divide it by height. So I didn't set up a systems of equations for that one. So for the third pi term, we need our elastic constant, which is our force times length. And then we're going to set up each of these variables in their dimensions and give them constants here. So when you set up these, you end up with 2a minus b equals 0, 1 plus a equals 0, then 1 minus 4a plus b plus c is 0. And solving that out, we get a is -1, b is -2, and c is -3. So our last pi term is k over our density times velocity squared over the base cubed. So that's how you set up your different pi terms for this problem.